first, let's get into the huge open source achievements and that you have in your past. So you are best known as the creator of not only popular but absolutely foundational Python libraries like NumPy, SciPy, and Numba. The Anaconda distribution, as we already alluded to with the logo on the
Yeah.
skyscraper. And so the Anaconda distribution is probably, if not the majority, the plurality of how most beginners, the plurality of beginners, start their Python journey. It makes it so easy to get all of the key packages that you need. Probably
Yeah.
most of our listeners used Anaconda at some point. And then whether they used Anaconda or not, surely any of our listeners who program in Python, which is probably most of them, have used NumPy and they have used SciPy for sure. So yeah, I guess there's so many ways that we could jump off from here, but I don't know if it would be awesome to hear how you got started with this, how you ended up contributing these absolutely foundational libraries from the start.
Yeah, well, I'll try to give a summary, a brief synopsis. I've actually given talks about this in several venues, and they're always just getting a slight window into the journey because it's a big journey. I would say I started with a need. I wanted Python to be useful for my work. I was a scientist at the Mayo Clinic, and I was doing 5-dimensional derivatives to try to do image processing on medical imaging data, in particular ultrasound and MRI data. And I was looking for tools to help me. I could code in C reasonably. I used MATLAB a lot, but I was running out of space. I needed to take more control. And I very, very much did not like the fact that if I wrote in a proprietary language, that I was essentially giving somebody a burden. If I said, here's my code, I love the scientific ethos of sharing progress. And if I shared progress with somebody, I didn't like the fact that I was actually telling them they had to have a license for some, I was kind of giving them a bug. I was telling them that was my problem. And so I was looking for something to be open source. At the time, there was lots of things out there, but nothing really very well developed. Came across Python, said, well, this is a pretty good language. Used it for a year. I'd used Perl before that, but then I went back to the code I wrote in Perl. I had no idea what I said. I was completely lost. But Python had the opposite experience. Used it in 97 for the first time. And then 98, I came back to it and said, wait, I understand what I did. And so that kind of said, well, I should do more here. And for the next since then, I've been basically trying to help make Python better for scientists. And so I guess because as a scientist myself, I had a better sense of what scientists would care about. And one of the things I noticed pretty quickly is that Python was a very generic computer programming language. So the benefit of Python is it's not just a scientific programming language, say like R, IDL, or maybe MATLAB. As an open source comparison, R is probably the closest, where R has been used by a lot of statisticians. But it didn't attract a lot of computer scientists, whereas Python did. Python had a lot of system administration, computer science work, but the gap between the computer scientists and the scientists in Python is real, was real, is still real. There's a real issue there that essentially I've been seeing that bridge for a long time, and a few other key pieces. In fact, that's a great place where anybody wants to really contribute to Python who has a science background. It's a great place to be a community worker, kind of somebody on the ground translating the needs to the people. And there's a few examples of people that have done that really well. I was one of the people that did that to some degree, but I was always driven by my need. So I started in 1998, essentially writing packages and extension modules for Python. One of the great things about Python is its syntax was accessible to non-programmers. So it didn't force you to learn all this arcane syntax to do anything. You could just write functions, so relatively straightforward loops. You could write classes, but you weren't forced to. They were available to you, but they weren't in your face, like you had to deal with them from the very beginning. And then you could extend it really easily, relatively easily. If I knew C, so I could kind of get at the root. And when I looked under the covers, I realized, Python itself is self-extended. It's not like, okay, here's Python, then the extension language is this extra thing that's kind of bolted on the side. Like, no, the integer, the list object, the dictionary object, these are all extension modules, essentially. And so I just made one. There was existing already a numeric extension. Someone had created an array object. It was Jim Hugonen. I've learned since, I know Jim. He hasn't worked in the Python space for years, but he built this incredible array module called numeric. He was a grad student at MIT at the time. And I was a grad student at the Mayo Clinic when this is all happening. So I just wanted to use it to write stuff. I was writing an MRI simulator. So that I was doing things to solve my problems. Like I wanted to read data in DICOM format so I could process it. So I wrote something called NumPy IO, which was a way to read data into an array object directly from a DICOM format. It enabled other things besides that. Then I was doing an MRI simulator, and so I needed to solve the block equations, which is an ordinary differential equation solution. And so I needed an ordinary differential equation solver, and I didn't have one. So I found this is when I found a bunch of Fortran libraries that already did that, and I just bound them to Python. Kind of wrote the glue to make them work with Python. That led to and just sharing that on the net, which I did. Just put it out there. Said, "Here you go." Of course, my sharing was pretty bad. I just said, "Here's a tarball with code and a website that looked terrible. That it was totally not accessible to anybody." But a few people used it, downloaded it. A guy out of Estonia downloaded it, Piero Peterson, and he gave me a better makefile. I still remember the day he gave me a better makefile. And now but it was more complicated and it did more. And so I was like, oh, that's pretty cool. I got a contribution. And that kind of started to get me hooked on just this community collaboration. I love the mailing list, the fact that I could ask questions and people a lot smarter than me would say things. And I'd be like, oh, that's a really good idea. Oh, that's cool. I can learn from that. And I kept kind of just engaging that way as a grad student all through. Then 1999 was the year I really dug in and said, we need more here. So I started basically that year. I probably released 6 libraries that year, all different libraries for integration, for special functions, for just a bunch of stuff. Along that year, Piero looked at it and said, why are you doing this manually? You're kind of taking Fortran libraries and manually creating extension modules. Here you go. I'm a real computer scientist. I will write a tool to build that. I'm a practical guy who's learned a lot of stuff, but my initial reaction wasn't to build a tool. My reaction was to get something so I could get my job done. Piero built something to help everybody solve the problem. So he wrote F2Py, and that just read the source code of Fortran, automatically built the extension module for you. So that interaction all happened in 1999, 2000, all while I was finishing my PhD. So by the time I got my PhD, I was knee deep embedded in the Python community and had lots of people who were using these libraries. And they were really, if you're an Anaconda user today, this is the early days. You did not have Anaconda. You had to make it yourself. In fact, I tell this story because it's so critical. It's got me on the path to Anaconda. Was a guy named Robert Krohn, who was a high school student at the time, and eventually a colleague at Enthought. He wrote not a makefile, but a Windows distribution for SciPy. Well, it was called Multipack at the time. So I had a tarball out there. If you're a Linux user, it was pretty easy to build. But if you're a Windows user, you're like, I don't even have a compiler on my system. I can't use this. But he basically built the tool and released a binary. So people just download the executable. So he built an exe file. And that service had been useful over the years of basically from 2000, from 1999 to 2012 when Anaconda got started for a long time. We had done something at Enthought too to make distribution easier. We were charging it for it. But you saw that need dramatically. And what I saw is an increase in users. The minute people could actually install it on Windows, 10x increase in usage, maybe. Like it was massive. So, I kind of reluctantly became a build person for Windows. wasn't not my favorite thing to do, but by 2001, I was tracking down build problems on Windows so that SciPy, which became the grouping of packages, we could release it. So SciPy started in really 1999, 1998, but became a fruition in 2001 as a partnership with a few other people, Eric Jones, Piaro, and others. Now it's grown. Now, the success of SciPy, again, I've watched this repeatedly, and so I kind of have some ideas about how do projects succeed. I've also watched them fail. So I've been a part of other projects that didn't go very far, or they failed ultimately. And so you learn as much from those two as the ones that succeed. But you end up with a kind of okay, here's a recipe for how do you know? And then part of it is things you know to do, and then some of it's out of your control. Some of it you just have to observe and see if it happens, and if it does, you can continue. If it doesn't, you have to kind of move on. But you've got to get other people involved. Like the reason SciPy succeeded was because it wasn't just, hey, I'm going to do all this work. It's I'm going to do work and then go engage with a bunch of people. Like go to conferences, go find other participants to involve, figure out ways to kind of grow the community. So that SciPy have succeeded today, and it has succeeded for the past, since 2000, at least 2013 probably, because of these hundreds of other participants, people who are making it work.
This sounds quite similar to, we had Gail Verocco on the show.
Yes.
Yeah, in episode number 737. talking about scikit-learn,
Yep.
and it was very much that it's this community involvement. It's the back and forth both ways.
Yes.
Yeah.
Nurturing the community becomes a really critical part of early stage open source development. And really early part. Scikit-learn is an interesting one actually, because I remember when scikit-learn got started because SciPy was trying to do too much. Like essentially SciPy had machine learning libraries. It had stuff in it that was SciPy became this kind of, it really was a distribution of Python masquerading as a single library, because the exe file, just getting it all installed was a big deal. And so it was easier to bundle, not unlike my conversation with Guido that took place, years ago, where I kind of asked him, well, so why don't you care about packaging? Like, we don't have a good packaging story for Python. What's going on? It's like, yeah, I don't care about packaging. If I want a library, I put it in the standard library. So it's like, well, that's cute if and SciPy had that same model, but scikit-learn was the scikits were like, hey, we got to have a way for people to share maybe documentation, maybe patterns of development, maybe a kind of some collegiality, but it's got to be controlled by different people, because that's when I really realized pretty quickly that people don't scale. You need lots of people involved, and so you got to incentivize those people too. And if you basically, this is definitely true that I've had to deal with, is yes, there's a lot of people who recognize me from things I've been involved with, and I was very, very critical to be involved early. But then I can create kind of a shadow. There have been people who have said this to me, and I won't name names, but and I've also watched it in others where they're like, I don't really want to be in your shadow. I don't want to be the Travis helper. I want to have my own brand. I want to have my own story, right? And they may not even articulate that to themselves like that, but I get that. I understand that. A key part of reason open source is valuable is because it does let developers have their brand, have their story. So there's got to be a way to make sure people get credit. That's actually one of the passions I have, is how do I help people get credit for the contribution they make, so it isn't just masked behind the one figurehead that pretends to take all the credit. I don't try to pretend to take all the credit. I really want to celebrate the successes of all the people that made NumPy and SciPy possible. If I get any notoriety, the goal of that notoriety is to drive towards activities that give other people credit. Like, that's the only reason it's valuable. Ultimately, is it can help consolidate message, so you're not dispersed. But how do I build systems so that other people? I want to incentivize this open source engagement and make it possible for people to build careers on it. It's kind of will lead probably to the other things I've been doing, but I'll try to finish more quickly. I'm trying to give some backstory for what I'm doing now.
Yeah, we'll get to that when we talk about open teams later on. I also just want to very quickly, in case people don't know, you mentioned Guido there
yes.
quickly, quite conversationally, and probably for many of our listeners, that is something that people just know. Guido van Rossum is the creator of Python.
Yes.
So that's just
wonderful individual. A lot of Python success is because of him as a community builder. And I've had the fortune of meeting with him, interacting with him, particularly as we got SciPy off the ground, and particularly as we got Anaconda off the ground. It's been a few years since I've talked personally with him, probably about 5. But he's a great guy. Really, really admire what he's done, and love what he's created. A lot of similarities. So SciPy got started that way. NumPy, so a lot of people don't realize SciPy came first.